Lifetimes and references are something that's starting to be accessible to users in this release. To be fair, the compiler has been internally reasoning about lifetimes since at least 0.6. And certainly this is a feature that has been in the works for a very, very long time. It's been requested a lot. And yeah, with 0.7, you actually start to have some control, and you can actually start to take advantage of it as a user of Mojo. So basically, what our long-term goal with Mojo is we want to make sure that this is a memory-safe language. And part of that is to provide the users with a model that's easy to use and basically guarantees that you don't leak memory, and also guarantees that if you don't want to deal with low-level details of managing particular resources, then you don't have to. And what we mean when we say lifetimes is pretty much the infrastructure around this. And the language features that allow you to form references and make sure that you don't have to think about destroying them. Destruction happens automatically, and that you can do this in a sort of very intuitive way, if you will. So if you come from a Python background, then we hope that this will become something that's completely invisible to you. But Mojo, of course, allows you to drill a little bit deeper. And part of lifetimes, when we say lifetimes, is also the ability to open the box and have a little more control over what's actually happening. One of the things that that is new in 0.7 is that now you can form references to objects explicitly. And I just prepared a little example. This is actually straight out of the changelog, and then in the second part of this demo, I'll put a little bit of sugar on it. But for now, I would just like to walk through this. And this starts with some pretty straightforward code. We just have some strings. And then the new thing here is that we're forming a reference explicitly to one of these strings. And the interesting thing here is what's going to happen to the object A in particular. So now this object A has something that references it. So if object A was to destroy, then of course this reference would be pointing to something potentially undefined or uninitialized. And the idea with Mojo references is that these references actually extend the lifetime of the underlying object. So when I say aref, as long as aref is in scope, I can be sure that I can access it, and I can be sure that the underlying object doesn't disappear. So what does this mean in practice? This means that, for example, I can take this reference and I can modify it. In this case, we're just concatenating another string to it, and then of course, being a mutable reference, I can try to just print the object that the reference was pointing to. And so to demonstrate this, let's see what happens if I run this. And as you would expect, you have something that prints the contents of A first, which is the original string. Let me just update this again. The original string concatenated with the second one. So we have hello references. And then I can keep mutating it, and I can keep using it. And the beautiful thing is that even though lexically the last use of A is here on line 7, the compiler keeps A alive and makes sure that even on line 12 you can still access its contents. So this is the idea behind references, and this of course is not copying A or anything like that. So this aref, it's a very lightweight thing. And if you are interested in the implementation details, this is implemented through pointers, but there's a little bit of extra metadata that allows us to track these lifetimes.